Unit 8, Day 3 Notes. Today we'll talk about rectangles, rhombi, and squares in more depth. A rectangle is a quadrilateral with 4 right angles. So, right angle here, here, there, and there. A rectangle is always a parallelogram because both pairs of opposite sides are parallel and congruent. Both pairs of opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. So what you'll notice is the rectangle still keeps all the parallelograms properties intact. So everything that a parallelogram was, so is a rectangle with the addition of 4 right angles. And this new fact that the diagonals are congruent. So again, just to reemphasize, you're going to have opposite sides parallel, like I'm marking as of right now. You're going to have opposite sides be congruent. Consecutive angles are supplementary. Opposite angles are congruent. Well, all the angles are congruent. They're 90. The diagonals bisect each other. But not only do they bisect each other, but they're congruent. All these 4 parts are equivalent. A rhombus is a quadrilateral with 4 congruent sides. So you have this side congruent with this side, congruent with this side, congruent with this. A rhombus is always a parallelogram. So the properties that a parallelogram has, a rhombus will also have. And when I say that, again, both pairs of opposite sides are parallel and congruent. Both pairs of opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. Now, there's also going to be some extra special properties regarding the diagonals. The diagonals are going to be perpendicular. And they are angle bisectors. So since the diagonals are perpendicular, they form a 90-degree angle on all four corners. And since they're angle bisectors, the angles get split in half on the vertices that they connect. So this angle is congruent with this one. This angle is congruent with this one. So that's two equal angles. This angle is congruent. And so on and so forth. So it bisects the vertice into two congruent angles. And a square is a quadrilateral with four right angles and four congruent sides. So a square is always a parallelogram. A rectangle, and a rhombi, because it contains all of the properties of both, all three of those figures. So you have your four right angles, you have your opposite sides parallel and congruent, so these are all congruent, and they're all parallel. These diagonals are angle bisectors and perpendicular. And they're congruent. So as you can tell, there's a lot involved in a square. A lot of hidden information that you have to just become familiar with. So it's time to practice. It tells us that ABCD is a rectangle on the left hand side. If BE, which is this piece here, is 6y plus 2, and CE, which is this piece here, is 4y plus 6, find y. Well, again, the the diagonals of a rectangle are congruent. And so that means that BE is equal to CE. So 6y plus 2 is equal to 4y plus 6. Subtract 4y on both sides, which would leave you with 2y plus 2 is equal to 6. Subtract 2, you will have 2y is equal to 4. Divided by 2, you'd have y is equal to 2. Excuse me. Alright, then it tells us the measure of BEA, which is this angle here, is 62 degrees. Find the measure of angle BAC. So BAC would be this angle right here. Okay. Well, we have a triangle where it's an isosceles triangle where the top angle, the vertex angle, is 62. So if I were to redraw it, it would be B, E, A, where this is 62 degrees, and our job is to find this corner here. So let's call that X. But since it's isosceles, this is also X. So that's 2 times X plus 62 is equal to 180 degrees. Subtract 62, you would have 2x is equal to 118. And then divide both sides by 2. And x is 59. No, x goes into 11. Or 2 goes into 11. 5 times. Yeah, 59. So it'd be 59 degrees. Alright, on the other side, the left hand side, it says ABCD is a rhombus. If the measure of ABD, so this angle here, is 60 degrees, find the measure of BDC, so this angle down here. Well, I know that opposite angles are going to be congruent of the parallelogram and the rhombus. And this entire angle here, ABC, is opposite of ADC, so they're congruent. I also know that on a rhombus, the diagonals will bisect the angles. So that means that if this corner is 60, this corner is also 60. So together it's 120. So ABC is 120, which means that ADC is also 120. And again, the diagonal bisects it and cuts it in half. So the angle we're looking for, BDC, is also 60 degrees. Now it says that AE is 3x minus 1. So this piece here. AC is 16, so that's the whole length. And it wants us to find x. Well, I know part of the whole. This is a part. This is also a part. And together, both parts make AC. So part plus part equals whole. So that means 3x minus 1 plus 3x minus 1 is equal to AC, which is 16. So that would be 3x plus 3x, which is 6x. Negative 1 plus negative 1, which is negative 2, equals 16. Add 2 to both sides, you have 6x is equal to 18, and thus x is equal to 3. And our last example, it says MNPQ is a square, so that means all sides are congruent, all angles are right angles. Well, all four corners are right. PQ is 8, so this is 8. Find each measure. So the first one it wants us to find is QM. QM is this side down below. This is QM, and it's the same all around, so it's also 8. PM is the diagonal. So essentially you have an isosceles triangle, where isosceles right triangle, where you can use Pythagorean's theorem. So this is 8, and we're looking for this side, so that's x. There's several ways of doing it. You can recall that it's a 45, 45, 90 triangle. And if you can remember that, that's less work on your part. Since it is a 45, 45, 90, you know that across from 45 is x, and across from 90 is x root 2. So x in this case, the sides that are the same, in other words, are both 8s. So that means across from 90 is 8 root 2. So MP is 8 root 2, which is the exact answer. MAQ is where we're headed next. MAQ. So when I trace it, it's essentially this corner right here. Again, it's an isosceles triangle where you know the bottom two corners are 45, and you also know that on a rhombus the diagonals are perpendicular, so there should be a 90-degree angle here, and if there's a 90-degree angle there, there's one here. So the angle we're looking for is one of the 90-degree angles. And last but not least, we're looking for APQ. If I trace it, there's APQ. So it's this angle down in this corner. Again, since the diagonals are angle bisectors, it is cutting that 90-degree angle in half, so we're looking at half of 90 degrees in APQ, so we're looking at 45 degrees. And this concludes your notes for the day.